Okay. So till where we have done this?
Actually, we've done partial derivative. We've stopped and linear regression slide. We've done this.
Till
Yeah.
here?
Here. Yes, yes.
Okay, so you have a meeting with at 9? Yeah.
What?
You have meeting at
I have
9?
office. Yes, yes.
Okay, okay. So we have 40 minutes, okay?
Okay, that's it.
So need of regression analysis. Regression analysis helps us to understand the relationship between two or more variables by creating a predictive model. So if the output is continuous, so this is a regression problem. We know that if discrete, then we will apply the classification. If it's continuous value, then we will apply regression. So common example include predicting prices for firm stocks, etc. So we know that price can be in the continuous value. So for that, we can apply regression. And stocks also,
Yes.
the value can be between the decimal points. So we can also apply the regression. Predicting length of stay for patients in the hospital. So it can be any days and any hours, any minutes. So like it will also be a continuous value. So we can apply the regression. So linear regression is a machine learning algorithm based on supervised learning. So it's like linear is like one value with one output, one input, one output. Linear regression is a predictive model used for finding the linear relationship between a dependent variable and one or more independent variable. So in this way, you can check that X is the independent and Y is the dependent, or we can say this is input, this is output. Okay, so this
Yeah.
will be, of course, the continuous value. So we have to find A and B. It's like a straight line equation, like mx plus c, something like that. So this will be the slope of the line, and this will be like how much far from the origin. So is it okay?
Yeah. What is fast from the origin? A?
Far from the origin. I mean, if you just check here, we can have a example here. Yeah. So you can see here, if the line will be exactly from this one, okay, then it will be C will be 0 or A will be 0. But if it will be maybe they already have something like this. Yeah, you can see here. So if this value theta naught, we can also write it like theta naught plus theta 1 x. We can also write A plus bx. We can also write like mx plus c. So there are many ways we can write the equation. So the value of theta naught, it's a constant value. So it will depend on the, like if the value will be exactly 0, so we can say that at red line, it's exactly going through the origin, like 0, 0. Like this is x,
Yes.
this is y. So between x, y, this is like 0 value, x is 0, y is 0. So exactly from the origin, it will be 0. So if this will be 2, so it will, of course, it will from 2. Like this is 5, so it's like 1, 2, 3, 4, 5 something. So it's like exactly from 2. And if it's -1, it means it will be, the y will be -1, like this side. So you can see that it will be from down the origin. So in this way, if it will be like -2, so it will be from here, -2, something like negative points. So did you understand why this is using theta naught?
Yes.
Okay. And this value, like with the theta 1 value is like this. If this value is 2x, you can see that the slope is like this. If the value will be like 1.5, so slope is becoming less. If the value will be 1, so slope will be more or less. If the value will be 0.5, slope will be more or less. And the slope, if the value will be 0, then it will go to this line. So I don't know, we can put the notation here. Yeah, okay. So we can see if the value will be it will be like 1x, so it will be like this one line will be a little low. If it will be 0.5, the value will be more low. Okay,
Yeah.
so in this way, if this value x, the value with like theta 1 is here, so if the value will be 5, so maybe we will have this kind of graph. If value will be 6, so slope will be increased. So as the value will become high, so slope will increase. If the value will be low, the slope will be less. Okay. So can you see the line which I am drawing?
Yes.
Okay. Good. So how can we remove it now?
You want to remove?
Yes.
I think you have eraser.
Yeah, there should be razor here. Razor.
Just wait.
Apps. I'm just trying. I don't know where it is. Yeah. So it's come here. Okay. So I hope you understood how the
Yeah, that's it.
regression is working. Okay. So we can just go back and we can, yes. So this one is like, we know that how this equation works. So now dependent variable is continuous and this x is independent, and we have to find a and b. So how we will find? We will use gradient descent, and that we will learn now. So simple linear regression.
Okay, just wait, doctor.
Yes.
To find A and B, we will use gradient descent, right?
Yeah, gradient descent.
Okay.
Okay. That will come ahead. So then I will let you. So linear regression is a machine learning algorithm based on supervised learning. So if, for example, this is like we have some values here, and like the area of the house, and this is like price of the house. So this x is independent, and based on this size, we can tell the price of the house. Okay.
Okay.
So only one independent variable x here, and relationship between x and y described by a linear function. So for example, we have x here, we will apply the linear model, and then we will have some predicted value based on this linear model. So we can see here like simple linear regression. Simple linear regression uses traditional slope intercept form. What is slope intercept form?
For when we say y equal ax plus b.
Yes, similar like. Okay, so in that
Yeah.
case, we have the slope.
Okay.
I don't know. Okay, so where it's go? Okay, we can just check.
Doctor, what is the difference? What is the difference between y equal hypothesis for x, theta 0 plus theta 1x, and y equal wx plus b?
Wx plus b. It's same. Like if you see here,
Okay.
they have just used the values here. Like for example, this is the value and W representing here theta 1 and theta naught we can just say B. So all the values, because your professor has put pick some equations from some place, some equations from some place, so that's why it's like this. So if you see here, that's why I told you, like we can have the, why it's annotate spotlight. Actually, I want to write, but I don't know where it's going.
Doctor, do you have
Okay.
a pen?
Yeah, now is okay. Okay, so you can see mx, okay, mx plus c. Oh, it's something else. Vanishing pen. Okay, I will learn after that. So we can say that theta naught plus theta 1 x. So this one and this one is similar. Okay. So our algorithm will try to learn to produce the most accurate prediction. X represent our input data and hypothesis like H naught X represent our prediction. So you can see that this one, okay, and this one, it's almost similar. Okay.
Yeah.
So if we just go again next, yeah, here. So if you see here, the previous one we only have one like size, but here we have 2, 3, 4. We have the four independent variables, and the one is dependent variable, the price. Okay, so
Yeah.
in multiple linear regression, if we have, for example, simple linear regression, we have only one, and in multiple linear or multivariable linear regression, we have one dependent variable like price and more than one independent variable. Like it can be one, it can be two, three, four, how much? Okay.
And for example, x value, maybe it has more than one y variables, right?
No, actually, all these values, this value previously it was only depending on one variable, but now this y is depending on all these four variables.
So x variable may have more than one variable, right?
Yeah, so
Why?
you can see like here, this one is multivariate. Multivariate means we have more than one variables like x1, x2, x3, x4. X1 here
Yeah.
is size. X2 here is number of bedrooms. X3 here is number of floors. X4 here is age of home.
Yeah.
And this y, our hypothesis, it depends on all the values. Okay.
Okay.
Okay. So here you can see theta naught, theta 1, theta 2, theta 3, theta 4. So we have to find these values. Previously, we have only this constant and this slope. So slope and intercept was two values here, like mx plus c,
Yes.
or we can see a plus bx, something like this. But now we have different values. We have different variables, and with each variable we have a theta value. So we have to calculate all these values here. Okay.
So, doctor, what does that mean? Y equal hypothesis equal theta 0 plus theta transpose x.
Yeah, here you can see, because if we want to multiply this one with this one, we have to take the transpose. If you remember, we have the, I can just find the, it's vanishing pen. I actually really need the pen to explain these things.
Doctor, try the,
Mhm.
it's not a highlight, maybe in the, you see in the left side, No, in the right side.
Mhm.
You have a pen sign.
Can you check and then let me know? Hi, Wafa. Actually, I am in meeting, so I'll.
Doctor,
Yes,
you see the right side on the screen?
right side to screen. Yes,
Right side, right.
here.
Yes. This, yeah.
No, this is
Down,
something else.
you have a pen. Just click the pen.
This one,
No, pen. Yes, this
will
one.
answer. No,
Overall.
it's something else. We actually have to
Okay,
find
just the right side. Try the right side, left side.
this one.
Left side, yes. Yeah, also there is a pen. Try this.
Yeah, this is also some signature, but different. This one, no, not good. It's
Doctor, try, for example, this one, taskbar, home, insert, edit, tools.
here.
Yeah.
I think it should not. It should be in the here in annotate. Only this
Yeah.
example, spotlight, but this one is different.
Doctor, can you use Painter?
Paint, I can
Yes.
use, but the problem is we have to go there and here. We can only share one screen, one time. Okay, maybe I can just for now we can have this.
Okay.
Okay, so can you see this one?
Yes.
Okay, so this is our X, okay, and this is Y. So if we have only one X, okay, so this one is like we can have, if we have line exactly from this, so we will have C equal to 0. And if we will have mx plus C, so M will depend that how much the slope is this one. So I hope you understood this point.
Yeah.
Okay, so next one was the problem of the, yeah, theta transpose X. So this one, how actually it works, this actually like, for example, if we have theta naught, theta 1, okay, and theta 2. For example, we have these, okay. So if we have this kind of things, like this is one is x1, x2,
X2,
x3,
X3.
okay. So in this case, you can see this matrix is also like 3 by 1, like 3 rows, 1 column. This is also 3 by 1. So we know the matrix, the property that the rows of the first matrix must be equal to the rows of the column of the first matrix equal to the rows of the second matrix. You remember?
Yeah.
But if this is
Yes.
not equal, then we cannot multiply. So what we did, we actually apply like theta 1 and theta 2 and theta 3. So this is like we make it like 1 by 3.
A vector.
1 by 3. Okay. So this one will
Yes.
remain same like x1, x2, and x3. So now if you see this is like 3 by 1. So now it's equal. The column of the first column equal to the rows of the second column. Now we can multiply this. But this one is actually the transpose of this. So if this is theta, then this one is theta transpose. You know, we convert
Yes.
the columns
Yeah.
to the rows and rows to the columns. So that's why we
Okay.
write it like theta transpose and x. So this one we wrote here. So if we go back
Yeah.
to our original lecture, so that's why they wrote it like, because theta is similar, okay, and this one is the, yeah, so this one is the theta transpose x. So I hope you understood this line.
Yeah.
So we can go. Okay. Next slide. How can we go next?
Doctor, you have to cancel the process and the task bar. Up.
Yeah, okay, sorry. So here, this is similar, and they said we assume that x not equal to 1, because we know that in this case we can write in the same way, theta naught x naught plus theta 1 x1 plus theta 2 x2. So theta transpose x we can write in this way. Okay, so the x naught is equal to 1 because this column
Yes.
doesn't exist. So now you can just write the multivariate regression in this way. Okay.
Okay.
Yeah, so next is similar. We have size, we have price, so we can just, we have to set this column, set this line on the whole data, so that we get the regression line. How we can get that regression line? The goal of linear regression fits the best line to predict the value of y for a given value of x. So for example, we know that the here, for example, it's the size is like, for example, 800 feet square. So the value, the price will be maybe near to about 0.2 million. Okay, here maybe, or it will be. So it's same like if the value will be 1000 feet square, then the value will be like maybe 1.8 million, something like this. So,
Yeah.
so in this way, or 0.18. So it will be like, so this is the actual line. So we have to fit our line in this way that our value should be very close to the actual value. Then we can predict very easily. So the model gets the best regression fit line by finding the best theta naught and theta 1 value. Theta naught and theta 1 is similar, like theta naught will tell you about this line, how far the line is crossing to from the origin, and theta naught will tell the slope of the line. So slope intercept formula. Is it okay?
Yeah. Yeah.
So we will have different lines here, and we can set, how we can set, we have to find the value of theta naught and theta 1 by using the partial derivative. And gradient descent is actually using the partial derivative, and then they actually find the best line. They can, as in partial derivative, we make constant one variable, and we do partial derivative based on the second value. So maybe we can fix the theta naught, like the line can be fixed, and we can move the line from here to here, and then we can fix the line, I mean the naught one, theta naught, and then we can change the theta 1 value. So in this way we can have, we can move the line here. So in this way we can finally find the exact line based on the data. So how we will do this, we can check here, as he already explained we did. So if the value will be, we can just fix value of theta naught, we can consider it at 0. So in that case, the value will be, how the value will work, like we know that it will be like here, spotlight, and this one you can see the value will be maybe this one, then maybe this one, then maybe this one, then maybe. So it will exactly pass from there. So for example, we consider that the line is like the blue line is actually, we have got this, and now we will change it like this one, and we will change the slope. So in this way finally we will get our line. So this is our result. Okay.
But doctor, I have a question.
Mhm.
You see here in the graph is y equal to x plus 0. and y is equal to x plus 2 and 1.5x minus 1. How could we evaluate these values?
How can we calculate these values? Am I right?
Yes, yeah.
Yes. So this actually is way to, this is called optimization. So we will apply the gradient descent. Gradient descent, but actually we will fix the theta, maybe as I told you, we will fix maybe theta 1. Okay, we will fix theta 1 and we will only find the theta naught. Theta naught mean what we have to do is we have to find the if for example if we fix the theta 1, we have to find theta naught. So the line can be the red one, the line can be blue one, the line can be here, the line can be here. Okay, so we are fixing the theta naught, so line, the slope will be similar, so it will be like this. But after that, we, after each line, we will calculate the mean square error. So how we will calculate the mean square error after line? It will come next.
Okay.
Okay, so here you can see. So for example, if our line is this one we found, so we have to find the error. Actually the points, actual points are here. Okay, so we have to find the distance here and here, the distance here, because this is exactly on the line. So it means error for this is 0, 0, 2 points. But
0,
for,
yes,
yeah,
yes.
for this point we have this error, for this point we have this error. Actually the value should be here and y will be given this value. But in our case, for this value, our case is giving here to here. So this is the distance from this distance and this distance. So this is the error. Same like for this one and this one and this one. So each point we will calculate the error. This, how we will calculate this error? We will calculate by this formula. We know that mean square error formula. Mean square error formula is like we have to calculate the this is the our value, okay, and this is the actual value. So we have to calculate the distance, the difference between two values, and then we have to take the average and we will find the mean square error, how much error is given. So how we will calculate this? This is the line. Actually this is doing the same thing here. Like this is calculating the distance of like the error. This is actual value, this is our value, predicted value. So these are the error, the red lines are the error. So we will calculate these errors and finally we know that how much error is given. So then we will change this line. How we will change this line? Based on gradient descent, we will change this line like this. Maybe then we can convert the line now this, and now we can convert the line here, okay, or maybe there. So then we will again calculate the error. If the error is increasing, we have to change the slope. If the error is decreasing, we can just go up, up, up. So in this way we can finally find the error, and when the error will be minimum, that will be the best fit line here. Did you
Okay.
understand a little?
Yeah, a little.
A little, it's okay. For example, in this case, we have this start line, but actually when we will calculate the difference from each point, the error is very high. If this line could be this one, if our line could be like this one, maybe here, maybe error is minimum. Okay, so we have to
Yeah,
find
but
this line. How we can find this line? We have to calculate the theta naught and theta 1. How we will calculate that? We will change the values of, we can fix theta naught and we can calculate theta 1 and we can change the theta 1 value. If the value is like if the our line, if after each changing, we will calculate the mean square error. If the mean square error is increasing, we will change the side of the line. For example, we put the line here. Okay, we put the line here. And if the error is increasing, we will go again back. We will change line here. If our error is more decreasing, we can go again here. If the error is more decreasing, we will go here. So when our error is again increasing, we can stop here. Okay, this will be our way.
Okay. Mhm.
So this is our style. Okay, so next is मजे 10 मिनट रुक जा कट्टे चलते 10 मिनट रुक जा चलते भी सिर्फ 10 मिनट हाँ बस खत्म होने लगे 10 मिनट okay so this one is it's just talking about the cost function. We can say it like cost function, we can say loss function, we can say the objective function, we can say anything. Okay, so these different names are here as we discussed in last lecture. So we need a function that will minimize the parameter over data set. So what are the parameters?
Theta 1, theta 2.
Yeah, exactly, theta naught, theta 1, theta 2, whatever. And minimize,
Yeah.
we have to reduce the error. How we can reduce the error? One common function is
By
that is
using
often used is mean square error.
mean squared error. Yes.
Yes, mean square error, which measure the difference between the estimator, the data set, and the estimated value. So this is the actual value, okay, and this is the our value, prediction value. So when we put the line, we will get some prediction. So we will calculate the our value, and like this is actual value, this can be maybe the prediction value. So we can calculate the difference, and based on this we have to minimize based on theta naught and theta 1, and then we will get the loss. If the loss is increasing, we can change the value. If the loss is minimum, we can just stop here, and that will be our minimum loss. But how we will calculate theta naught, theta 1? This is like we are changing the value based on gradient descent. We will go again. Okay, so idea is choose theta naught and theta 1 values that h naught x, like our hypothesis is close to our training examples. Training example is actually the actual values. So we have to make the line so that the value should be very close to the actual value. So the line here will be very close to actual value. Okay.
Okay.
Okay, so this is like cost function. We use mean squared error at our cost function as our cost function. So the output is a single number representing the cost, a score associated with one outrun that weights. So the output is like this. Our goal is to minimize MSE, mean squared error, to improve the accuracy of our model. So again, he put the same, and this is the code of that. Okay, so I think it's easy.
Yeah, it's easy. Yeah.
Okay. So model representation to describe the supervised learning problem slightly more formally. For a given training set to learn a function so that h naught is a good predictor, it's talking about the same thing again and again. Okay. So it's also called hypothesis. So hypothesis is a function that takes input, the size of the house, and tries to output the estimated value, the price of the corresponding house. So maps input to output. So hypothesis is like it will take size and it will predict the price. So this is called hypothesis. And optimizing the cost, objective function, cost function, loss function, objective function. How we will optimize? One straight method is gradient descent, as we discussed. So gradient descent will theta naught and theta 1 are initialized randomly with start. Okay, in the start it will be randomly initialized. We can take any theta 1 and theta naught. Then using gradient descent, we will update the theta naught and theta 1 values to minimize the cost function. So we have to change these values. Okay, like we can change the slope, we can change the intercept, and based on these values, we have to minimize the cost function by using mean square error. Easy?
Yeah, easy, Dexter.
Okay. So the idea of any machine learning algorithm is to minimize the cost function. So we have to minimize the error so that the hypothesis is close to the original dependent variable. What is the cost function or loss function? We have to find the hypothesis which should be close to the original dependent variable. We know that what is actual value. We have to make our value close to the actual value. So we need to optimize the theta naught and theta 1 values to do that. How? If we take the partial derivative of the cost function based on theta naught and theta 1 respectively, we will get the gradient descent. Okay, so we have to take the partial derivative. Like we can fix theta naught and we can find the partial derivative of theta 1. Then we can fix the theta naught and we can take the partial derivative of theta naught. Then we can find the line, exact line. So as you can see here, cost function and gradient. To update the theta naught and theta 1 values, we need to deduct the gradient descent from the corresponding value. So as you can see how we can change the theta naught, it's like theta naught previous value minus alpha, which is learning rate, and this is the partial derivative based on the theta naught. Okay, so when we have partial derivative of the theta naught and this is with the learning rate, and we can just take the previous value and we can minus this value and we will get the new value. Same we will apply with the theta naught. Like we have the previous value and we have the learning rate and we can take the partial derivative with respect to theta 1, and then we can just minus from the previous value, we will get the new value. Okay, so in this way, this is the gradient descent formula, simple. So we can take the partial derivative with respect to theta naught, we can take the partial derivative with respect to theta 1, and we will get the new values. Okay, so after the partial derivative, the formula above will turn out to be like this one. We know how to take the partial derivative. Very simple. As we done. So no need to.
Doctor, can you give me an example? A lot of just not a lot, but I need examples. Actually, I'm not good enough in partial derivative with theta.
With theta? So just consider this one. For example,
I know the idea. Yeah, I know this idea, but when I want to apply with the cost function, I used to confuse.
Okay, I understood. So I think currently we have only 5 minutes. I can just explain you a little, okay?
Okay.
So here, for example, we have the values. For example, here, we can consider that we have theta naught in start. We have considered at theta naught equal to 2, okay, and theta 1 equal to 1. For example, this is our start, okay, and now we have to apply this one on the actual values. For example, we have y equal to mx, like theta naught plus theta 1 x. Okay, so if we consider we are taking the partial derivative of y with respect to theta naught, if we are taking the partial derivative with respect to theta naught, so this this will become, it's 1, okay, and this will be finished because there is no theta 1. So it means this value theta naught is 1, okay. And again, if we are going to change anything, if we are taking the partial derivative with respect to this is fixed here, but we cannot change this one. But if we can change with this with respect to this, so y equal to theta naught plus theta 1 x. If this one, we can just take the y with respect to theta 1, so it will be theta naught, this will be 0, okay, and what will become this one?
X.
This will become x, okay. So whatever the value of x will be, it will be like we will get this. Now we can take the actual example. For example, if we apply the value of theta 1 as fixed, so if this is 2, okay, theta 1 currently it's 1, okay, and we don't know about the x. So now we can apply our formula with the theta naught equal to theta naught plus what were the value? There was alpha, and then we have the partial derivative here. And what is
it's not plus, it's minus.
It's minus here. Okay. So this one is
Yeah,
minus.
minus
Yeah, exactly.
minus learning rate, and
Minus.
we will add
We will add
the
the derivative.
derivative of
Yeah.
yeah, it's 1.
So for example, if this is x, okay. So in this case, for example, because we have theta naught, so theta naught derivative was 1. So it's like only 1. So if our this one is also theta is like learning rate 1, so we can just say our previous value was 2 minus 1 equal to 1. Okay, so if our again if we go next time, so it will become 1 minus 1, it will become 0. So then it will be minus 1, then it will be minus 2. So based on this, if our alpha is very high, alpha is like we have to make it like between the points like 0 0.2, 0 0.3. If this value will be very high, so it will changing very abruptly. So in this way, we can change this value theta naught. In the same way, we can apply it on the theta 1. So we will also change the values. So actually, we have to do it on the notebook, and then we can check like how our actual line is going to change. So as we can see, we have to check every changing values when we will apply theta naught and theta 1. We have to check how much changing is given based on the mean square error. We will check the loss. If the loss will be low, then we can just stop it. Otherwise, we can just continue it. So maybe we can continue in the next lecture from here. Okay, we can have a proper example, and maybe I can find some example for you. Then you can have a just go through the whole line. Is it okay?
Okay, doctor. Yeah,
So, but
doctor, the
Mhm.
what?
You can just
Our
check.
session is a start.
Yeah, I know. So you can just check this one here. So it's exactly doing the same. So maybe you can find the gradient descent here. Okay, maybe we can continue this with the next lecture. Okay.
Okay, doctor.
Okay. Allah Hafiz. Goodbye.
Yeah, thank you, doctor, so much. Good luck. Doctor, in which time we will complete tomorrow?
You can just decide anytime because
Doctor, is it good in the morning?
yeah, for me is okay. Whenever you want.
Hmm?
I have only one class for half an hour. So I will let you know. You can just decide any time and I will like we can start. Okay.